Alright guys, so it's time to move on to Newton's third law, final law of motion. Okay, so I hope the Newton's second law practice went well. It is assumed that you've done that homework before you try to approach Newton's third law because Newton's third law problem solving will use Newton's second law a lot. So let's review the first and second law and see how the third law is different. The third law might be the most challenging to understand, but mathematically it is actually quite straightforward. So let's review the first two laws and then introduce the third one. Okay. So of course our first law is object will remain at rest or at constant velocity unless an unbalanced force acts on it. F net equals 0 for mathematical. And then our second law says the acceleration is directly proportional to the net force it experiences and inversely proportional to the system's mass. F net equals ma. Okay, so the difference between Newton's first and second law and the third law, we're going to group these two together and the third one on its own, is that the first and second law deals with one or more forces acting on one system. Okay, so that's important. We're looking at all the forces acting on a system and we're going to see if it accelerates or doesn't, right? So those are first and second law. The third law is different because what the third law is we're looking at interactions between two or more systems and then the forces that connect them. Okay? So what that means is when two objects interact with each other, so for example, say my calculator is interacting with the table, right? The calculator imparts a force on the table and the table imparts a force on the calculator. Which force that is, that's a normal force because it's two contacts interacting with each other or two surfaces interacting with each other. So let's introduce Newton's third law and then come back to that idea. Okay. So Newton's third law states every force comes in pairs. I should say force, not forces. Every force comes in pairs. Okay, odd. Forces are an interaction between two objects. That means if a force, if an object A pushes on object B, then object B pushes on object A with the same force but in the opposite direction. Okay. So in order to understand this, I'm going to review back when we did this elastic activity in class, where we took an elastic and put it between your two fingers. Because this one really demonstrates Newton's third law really well. So when you had your fingers separated by this elastic, each finger experienced an elastic force, right? So that elastic force is the force that is applied to both systems that allows the two systems to interact. Okay, so the force that the left hand applies on the right hand is the same but opposite direction to the force that the right hand applies to the left hand. And so we get this interesting notation with the third law. Okay, the two elastic forces are equal but they're opposite direction. We're going to redraw those two elastic forces on this picture and show what that means. Okay, so this finger experienced an elastic force, okay, right, to the right, and then this finger experienced that elastic force to the left, but it's the same force, right? It's an elastic force. But the elastic force of the left hand, the right hand on the left hand goes to the right, and the elastic force of the left hand on the right hand goes to the left. So they're basically, it's like one force, it's the elastic force, but each system experiences that force. They're the same size, but they're opposite direction. Okay, so mathematically, it becomes that the two, it looks like two forces. They're not two forces. It's one force, but it comes in a pair. So the elastic force experienced by the right hand so it's the left hand on the right hand, is equal and opposite, so we put that negative sign, to the right hand on the left hand. So they're equal in size but opposite in direction. We're going to see what this looks like mathematically in a little bit. And like I said, it's a bit non-intuitive to understand what it means to be one force but two forces, if you know what I mean. So I will be providing a couple of extra videos here to help you understand this. But your textbook is probably going to say the following. Okay, so they'll say that Newton's third law is for every action there's an equal but opposite reaction. Okay, this is problematic because to say that there's an action or reaction is to say that something is like happening because of something else. So for example, if I flick the pen moves because I flicked it. That's not the action-reaction. Basically what happens is during that interaction, during the time that I'm touching the pen applies a force on me and I apply a force on the pen. That's the third law difference. Okay, so I want you to actually read this article. It helps clarify the difference between those two very different definitions of Newton's third law. Okay, and then we're going to come together and we're going to do some problem solving with Newton's third law.